Assalamualaikum and hi everyone. We are from Group C, Section 5. Today we would like to present Hydrology Group Project. First of all, I would like to introduce our group members, which is me, Ili Maisara, Aisyah Jamila, I'm Afifa, and Siti Naziha Umairah.
I will present the introduction of our project. Floods are natural events that occur when water overflows from water channels such as rivers, lakes, or seas and inundates dry land. They are defined as temporary conditions where water levels exceed normal levels or failures due to heavy rainfall. Floods are common in Southeast Asia, where Malaysia experiences a tropical climate with heavy rain, leading to flash floods or river floods. These sudden complex disasters cause loss of life, property destruction, and environmental damage. They can also cause infrastructure damage, damage homes and buildings, and disrupt transportation and economic system. Malaysia, located in Southeast Asia, is susceptible to monsoon rains and severe weather conditions. The country experiences two monsoon seasons, southwest monsoons from May to September and northeast monsoon from November to March. Heavy rain can cause rapid water accumulations, excess drainage system, and river overflows. Over the past few decades, floods in Malaysia have become a serious problem, affecting people's welfare and the country's economy. Kuala Lumpur, the capital, is often hit by severe flood disaster due to its decent populations and the Klang River Valley where many tributaries converge. The Jamek Mosque, situated at the confluence of the Gombak and Klang rivers, is also susceptible to flood risk. Heavy rain for over 2 hours in the capital caused flooding in areas and roads around Masjid Jamek and surrounding areas. Floods in Malaysia significantly impact infrastructure, agriculture, public health, displacement, and personal property. With a population of 5.7 million, floods affect about 10.1% of Malaysia's total area, causing annual losses of 1.15 billion ringgit. High sedimentation risks in rivers cause frequent and violent floods in downstream communities. Flash floods are more common in metropolitan areas due to built-up drainage characteristics. Flooding affects 12% of Malaysia's population, affecting an estimated 29,000 kilometers square, which is 9% of the country's land area. Annual flood damage is estimated at 29.3 million on average. Floods cause high deltas, disease outbreaks, property and agricultural damage, and other intangible loss annually. This study discusses flood control mechanism, water loss caused by flash floods, and socio-economic impacts. In conclusion of our project, the hydraulic gate flood barrier is one of the good alternatives to prevent flooding and reduce the risk of flooding in the area. It can also save life of people and public property near the flood area. This hydraulic gate is an important element for our country because our country is one of the countries that often experience floods. Hydraulic gates play a crucial role in preventing and mitigating the impact of floods. Their ability to regulate water flow, divert water, store and release water, and facilitate emergency responses makes them essential components of flood control infrastructure. By effectively managing water levels and flow rates, hydraulic gates help prevent excessive water accumulating and redirect water away from vulnerable areas. They contribute to the overall integrated flood management system, working in conjunction with early warning system, flood forecasting, and other protective measures. Additionally, hydraulic gates are instrumental in coastal flood prevention by controlling water flow during high tides or storm surges. The water that accumulates when the gate is closed will enter the underground tank space to reduce and prevent flooding. Overall, hydraulic gates are vital tools in flood prevention efforts, helping to safeguard communities, infrastructure, and the environment from the devastating impacts of floods.
There are 4 objectives of our project. First, reduce the risk of frequent floods in the area. Second, ensure that the water line can function properly. Third, reduce public damage caused by flood disasters. And the last one is apply technology in dealing with flood problems.
Here is some of the issues that become the reason the occurrence of the flood. First of all is clogged drain. Clogged drain is caused by the incorrect disposal of waste such as dumping trash or pouring substance like paint, oil or chemical down the drains. With a high concentration of food establishment, grease and fat solidify. And structural issues such as damages or deteriorating drain pipes due to age, corrosion, and cracks, collapses, or misaligned pipes can disturb the water flow. Secondly, limited natural and poor drainage infrastructure. As we know, there are complex network of drainage systems, including storm drains, sewers, and canals. Drainage system may be inadequate or poorly maintained, and block drains insufficient capacity or improper design. Systems were not created to handle such an immense volume of water that happens during extreme rainfall. Third is urbanization. As we know, there are rapid urbanization and expansion of Klang, which increase the areas of concrete and asphalt surfaces used. These surfaces will impede natural absorption and prevent water from being absorbed into the ground. This will result in faster surface runoff and a higher volume of water flowing into the drainage system. This is because the water will instead rushes over these impermeable surfaces. The fourth one is human activities. Such as we know, the human will dump trash into the drains without the common sense. This will make the rubbish accumulate in drains and canals, which restricts the flow of water. The fifth one is heavy rainfall. As we know, Klang is located in Malaysia, which experiences monsoon seasons characterized by heavy rainfall. These intense and prolonged rainfall events can overwhelm the drainage systems in the city. There are reports on 16 November 2022, continuous heavy rain in the Klang Valley overnight caused floods in several Selang districts, among them Sepang, Hulu Langat, Petaling, and Klang. The sixth one is topography. Klang is situated in a low-lying coastal area, which is susceptible to flooding, especially when coupled with heavy rainfall. The city's flat terrain and proximity to river will make the water accumulate quickly and inundate surrounding areas. 7. Land development practices. For examples, deforestation, inaccurate soil management, excessive paving, and inadequate green spaces. This will increase the surface runoff, reducing infiltration capacity and causing sedimentations in the waterways. Without sufficient areas for water absorption, rainwater will quickly accumulate in the drainage system. The eighth one is climate change. As we know, the climate change will alter rainfall patterns and stronger storm. This will alter the timing, duration, and intensity of rainfall events. The longer dry period followed by more intense rainfall within a shorter time frame. This will make the soil become less able to absorb the sudden influx of water. The ninth one is inadequate flood mitigation measures. In Klang, there are absence or insufficiency of flood mitigation infrastructure. For example, retention ponds or flood control barriers. These measures are designed to temporarily store excess water during heavy rainfall events and regulate its release. And last but not least, the 10th one is the growth and nourishment on waterways. Nourishment and improper development along rivers, streams, and natural drainage channels can disturb the natural flows of water. These waterways are obstructed by buildings or structures which water cannot flow freely, leading to localized flooding and increased vulnerability to flash floods.
Next, I will continue about construction process. This is hydraulic gate. During the 1950s and 1960s, Osaka often experienced typhoons that caused damage to public facilities and also claimed many lives. Not only that, but typhoons can also cause flood and tidal wave phenomena in area. Osaka has suffered tremendous damage from this major flood. So, residents in Osaka are very worried and afraid of the situation in the area. As a result, the Osaka-based storm surge countermeasures has built a hydraulic gate system to address these problems. Interestingly, this hydraulic gate is shaped like an arch-shaped gate and can be opened and closed as needed. The special feature of this gate shape is that it also allows ships to enter and exit through this gate at any time. When a flood occurs, this hydraulic gate will be closed to prevent excess water from entering the area, and it will rise again for the passage of ships in the area. The cost of building this system is quite expensive depending on the size and material used. The process of making these systems also takes 20 years to complete. Although it is expensive and takes a long time to build, it is very useful and can last for a long time. Next, this is process of our project. The study area near the Tom Perak Bridge in the Klang River area is being studied to prevent flooding. To achieve this, a hydraulic gate is being built, consisting of a gate structure, hydraulic arch, hydraulic power units, control systems, and associated components. The hydraulic power unit generates the hydraulic pressure required to operate the gate, which can be electrically powered or driven by a diesel engine. The hydraulic system allows operators to manage the gate's movement, including control panels, switches, and sensors. Advanced systems may also incorporate automation and remote control capabilities. The hydraulic gate will be closed to prevent excess water from entering the area and will rise again for ship passage. The water retained by the hydraulic valve will be channeled into subsurface reservoir, which act as a groundwater flood reservoir. This reservoir can contain excess flood water during flooding, reducing flooding to the soil surface. The water stored in the reservoir can be used for road cleaning and fire suppression systems, reducing water consumption.
Next, I will explain about the material that we use. The material used to build the system is stainless steel mixed with nickel. This is because steel has a high strength and durability and is not easily damaged. In addition, the flexible and lightweight nature of steel makes it easier to form the main panel, which is the door, according to the width and breadth of the river. The system structure are using the first one, depth in the ground 60 meter, gate panel thickness 0.3 meter, gate panel weight estimate 6 meter. The material for the underground tank is concrete. Concrete is the main material used for making tanks because it has stronger strength and durability and is suitable for underground tanks. The depth of this tank is 10 meters and has a width of 50 meters in diameter. The tank can hold 1,767.85 liters of water that is channeled from the river that accumulates after the gate panel is closed. After that, this is a method of our project. First, this hydraulic gate functions as a barrier to prevent water from overflowing. This hydraulic gate is placed in the section as shown in figure 12 to prevent water from flowing directly towards the flood area. The second one, the underground water tank functions as a reservoir for water that is channeled from the nearby river. This tank can hold up to 1,767.85 liters of flood water and can reduce the risk of flooding in the Klang River area near the Tom Perak Bridge. When the tank is full, the water inside will be used for non-potable purpose such as cleaning roads or firefighting systems after the flood has subsided. Underground water tanks are used for storing water from rainwater harvesting systems. It can be used to store municipal and water from other sources from household use. Underground tanks can be used as a water reservoir for irrigation systems. Emergency supplies of water can be safely stored for long periods underground. For the technology, we are applying the hydraulic gate. A hydraulic gate, also known as a water control gate or a water barrier gate, is a type of gate or barrier that is operated using a hydraulic system. It is commonly used in water management and flow control system to regulate the flow of water in rivers, canals, reservoirs, and other water bodies. The benefits of using hydraulic gate is precise flow control, efficient operation, high load capacity, and reduced maintenance. Application of the hydraulic gate. Hydraulic gates are operated by hydraulic systems that use special fluid, usually oil or water, to power the opening and closing mechanism. The hydraulic systems typically consist of hydraulic cylinders, valves, pumps, and control systems that allow for precise control of the gate's movement. The operation of hydraulic gate is manual. Hydraulic gate play a crucial role in managing water resources, preventing floods, regulating water level, and facilitating navigation in waterways. Their precise control and ability to handle large water volumes make them essential components of water management infrastructure. Next, gate opening and closing. The gate is controlled by a button that can make the gate go up and down when necessary. To open or close the gate, the hydraulic power unit activates the hydraulic cylinders. The cylinders are connected to the gate structure and exerts force to move the gate. The hydraulic fluid is pressured by the hydraulic pump and directed to the cylinders through the control valve. The control system of a hydraulic gate allows operators to manage its movement. It includes the control panel, switches, and sensors. This advanced system may also incorporate automation and remote control capabilities. Next, the installation of the hydraulic gate. First of all is installation of the gate structure. Install the gate structure including the gate frame, gate panels, and any associated components. This may involve in welding, bolting, or other methods of attaching the gate components securely to the foundation or supporting structure. Then we can continue to the hydraulic system installation, which installs the hydraulic system components including the hydraulic cylinders, valves, pumps, and control systems. Connect the hydraulic components to the gate structure and ensure a proper alignment and functioning. Next, for the maintenance, a regular maintenance schedule to ensure the gate's ongoing performance and longevity. Regularly inspect and service the hydraulic components to monitor the system performance and address any maintenance or repairs needs promptly.
In conclusion of our project, the hydraulic gate flood barrier is one of the good alternatives to prevent flooding and reduce the risk of flooding in the area. It can also save lives of people and public property near the flood area. This hydraulic gate is an important element for our country because our country is one of the countries that often experience floods. Hydraulic gates play a crucial role in preventing and mitigating the impact of floods. Their ability to regulate water flow, divert water, store and release water, and facilitate emergency response makes them essential components of flood control infrastructure. By effectively managing water levels and flow rates, hydraulic gates help prevent excessive water accumulation and redirect water away from vulnerable areas. They contribute to the overall integrated flood management system, working in conjunction with early awareness system, flood forecasting, and other protective measures. Additionally, hydraulic gates are instrumental in coastal flood prevention by controlling water flow during high tides or storm surges. The water that accumulates when the gate is closed will enter the underground tank space to reduce and prevent flooding. Overall, hydraulic gates are vital tools in flood prevention efforts, help to safeguard communities, infrastructure, and the environment from the devastating impacts of floods.